This video is on Integrated 2, Chapter 10, D-Day number 1. So on this first problem, first two, what we're doing is we are trying to find the inverse for each of these. So what we're going to do is we're going to switch our x and y. Remember, f of x is really just a fancy y. So I'm going to go x is equal to negative 2y minus 8. And then we are going to get this to be in y form. Okay, so we're going to add 8. Then divide by 2. And really, you could do this two ways. You could have x plus 8 divided by 2 is equal to y. Or we could have separately divided the x by a negative 2 and the 8 by a negative 2. And that would give me a negative 1/2 x minus 4 is equal to y. Both of these answers are acceptable. If I had to graph it, the second one's probably a nicer form than the first one. On B, again, we're going to switch our x and y. So I'm going to go x is equal to 3 times y minus 6. I'm going to divide by 3, and I get y minus 6. I am going to add 6. So x over 3 plus 6 is equal to y. Or you can think of it as a 1/3 x plus 6 equals y. That's the same. On number 2, for all of these ones, what we're doing is we're going to be trying to find x. So on 2a, what we want to remember is when we have a central angle, it is going to be the same as the intercepted arc measure. And it is going to be double our inscribed angle that forms that same arc. So I am going to take 76 divided by 2. And x is going to end up being 38. On letter B, so we are trying to find x, which is right here. What I do know is that since this inscribed angle is 38, that means that this arc measure is going to be double that, which is going to be 76. And if that is 76, then this central angle is also going to be 76. And x and 76, those are vertical angles. So my x is going to be 76 degrees. On C, this is a radius that is touching or meeting at the point of tangency. Okay, that's the point of tangency. So that means that this has to be 90 degrees. So we have this triangle here with a right angle. We know we have a 41 degrees and a 90 degrees. So I'm basically going to take 180 minus 90 minus 41, and that's going to be my x. And really, I would just do 90 minus 41 because I already know 90 is gone because of the right angle. And we end up with our x is equal to 49 degrees. On D, this inscribed angle is 42. It forms this arc. So that arc measure is going to be twice that. So it's going to be 84 degrees. On number 3, we want to come up with the equation for the circle. So first thing I'm going to do is find my center. And so that center is at 3, -2. So that means we're going to have x minus 3 squared plus y plus 2 squared equals, and then my radius is 3. So that means this is going to equal 9 because it's always equal to 3 squared. On number 4. So on 4 in circle O, calculate the angle of AOM, which is this right here. So that is a central angle, and it is going to be the same as the arc measure of the intercepted arc. So it is going to be 30 degrees. Then we want angle T. Angle T is an inscribed angle that forms that same arc, and that means it's going to be half of that. So that's going to be 15 degrees. And then this was supposed to have an arc symbol on it. So the measure of arc MHT, so MHT is all the way to here. So I'm going to take 360 minus 104 minus 30, and that's going to give me my answer. So 360 minus 104 minus 30, we end up with 226. So that's going to be 226 degrees. On number 5, we're going to be graphing these. So the vertex for this is 1, 2. So we are going to be going to 1, 2 and put our vertex. So that's going to be right here. And then from there, what I'm going to do is the radius, I'm not radius, sorry, the stretch is 3. So from here, if I go out 1 from my vertex, let me scooch in a little more. So if I go 1 from my vertex, 1 squared is 1. I'm going to times it by my stretch of 3. 1, 2, 3. Same on both sides. And if, so try and get that center better. Okay, so we went over 1. 1 squared is 1, times it by 1, 2, 3. If I go out 2, 2 squared is 4, times 4 by 3. I'm going to go up 12. So 1, 2, 3, 4, 5, 6, 7. That's going to be off my graph. Now, remember, when we graph this, it is a curve. It is not a V like an absolute value. On number 10, with this as a circle, the center of the circle is -2, 3. So in orange, I'm going to go to -2, 1, 2, 3. That's my center. Now that's not my graph. For my graph, I am going to go out what my radius is, and my radius is going to be the square root of 10. And the square root of 10 is going to be in between 3 and 4, closer to 3. About a 3.2, let's say. So we're going to go out from here, 1, 2, 3, a little beyond 3. Let me make this a little bigger. 1, 2, 3, and a little bit. 1, 2, 3, and a little bit. 1, 2, 3, and a little bit. And then I'm going to grab my circle shape, hold shift while I do it. I'm going to start at one of these points and drag it out. Let's let go of it. Okay, and there's our circle. Now, this is not going to be being perfect here because this looks like the graph paper is a little bit made into a rectangle as opposed to a square. Okay, so there's the best we can do. Okay, on the next one, we want to write this in graphing form. So I'm going to get my x's together and my y's. So I'm going to have x squared minus 4x plus y squared plus 2y. And then I'm going to take the 4, that minus 4, and take it to the other side. And then what I'm going to do is I am going to take half of -4, which is my b, which is -2, square that, which is a 4. That's what I'm going to add here and here. I need to add it to both sides. Then I'm going to do the same with my y. So y squared plus 2y, and half of 2 is 1, and 1 squared is 1. So I'm going to add 1 here, and I also add 1 here. And so we end up with 9. So this becomes x minus 2 squared plus y plus 1 squared is equal to 9. And then they want us to graph it. So the center of my graph is going to be at 2, -1. And then from there, we're going to go out 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And we have our circle. On 7, 8, 7A, B, and C, we're solving quadratics. In this case, I have 4. I have 4x squared plus 5x minus 6 equals 0. And I do believe this is factorable. So I have my 4x squared here, my -6. That is going to multiply to a -24x squared, and it has to add to our 5x. So that's going to be an 8x and a -3x. So one of these is 8x, the other one is -3x. And then this is going to be a 4x and an x minus 3. And then this is going to be plus 2. So when we're solving this, we're going to have 4x minus 3 times x plus 2 is equal to 0. And when I set 4x minus 3 to 0, I'm going to get a positive 3/4. And when I set x plus 2 to 0, I get a -2. And those are our 2 answers. Now on the next one, I'm personally going to multiply everything by a negative. So I have a positive 3x squared now, a -x, and -1 equals 0. This one I do not believe is factorable, so I'm going to use quadratic formula. So -b plus or minus the square root of b squared minus 4ac all over 2a. And my b, again, I'm looking at it right here when I rewrote it. So that's going to be a positive 1 plus or minus the square root of 1 squared, which is 1, minus 4 times my a, which is 3, and my c, which is -1, all over 2 times the a, which is 3. So we're going to get 1 plus or minus the square root. And we're going to get basically 13 over 6. And those are our 2 answers. So we got irrational answers on that. On the next one, I'm going to have my x squared. I'm going to bring over my 8x, but I think I'm going to keep my negative 25 over here. And I'm going to complete the square. You can also do quadratic formula, but have your 25 with your x squared. So in this case, half of 8 is 4, and 4 squared is 16. So I'm going to add 16 here. I'm going to add 16 here. So we're going to get x plus 2 squared is equal to negative 9. When I do that math, I take the square root, I get x plus 2 is equal to, and I take the square root of anything, I get a positive and negative. Because I'm taking the square root of negative 3. So my answer is going to be negative 2 plus or minus I root 3. On number 8, so this is called a piecewise defined function where you have more than one function and you're only graphing a portion of it. So this first one here, if I type it in here just so you can see what it is, it's actually going to be a line. And this is kind of looks like a parabola, but this is also a point slope form where the point is going to be 2, 3, just like if it had been a vertex. Then my slope is going to be up 1 over 2. So let me just put this in so we can see. So y is equal to 1/2 the quantity x minus 2 and then plus 3. So if you look at this graph, just so you see, if I was to put in a 0.2, 3, you see here is 2, 3. That is a point on the graph found right here from this and this. And then I go up 1 over 2. Okay, that's what this graph is. Now, on this graph, we're not graphing all of it. So we have a restriction, 0 less than or equal to x less than or equal, not just less than, not less than or equal to. So let me get my x in here. And then less than 4. Now really here, this would be an open circle. Okay, that would really be an open circle, but you can see here's a portion of it. We're only going from 0 to 4. The second one is basically a horizontal line, y equal 4, but I'm not going to go forever and ever and ever like this. They want us to go from 4 less than or equal to x less than 7. So in between 4 and 7, but not including 7. So this actually would be an open circle. The next one is y equal x, which is this diagonal line. And then I have a restriction where we're only going from 7 less than or equal to x less than 10, not including 10. So let me just make this a little bigger. And so this is my graph. So you'll notice that here, my first point, I'm starting at 0, 2, where I put a 0 in, and it ends, but it's actually going to be an open circle at 4, and you can see 4 is undefined. Now on this one, 4 is defined, y equal 4, and it's going to be y equal 4 until we get to 7. Once we hit 7, it's going to jump up here to this y equal x. So anytime I see an equation in this form, I basically think of this as I know a point and I know a slope. A point is going to be 2, 3, just like if I was going to identify a vertex. So I would be starting at 2, comma 3. And then I'm going to be going, make this a little fatter. I am going to be going up 1, out 2. And I would keep going, but I don't keep going forever and ever because it's only from 0 to 4, not including 4. So I'm going to actually take this point. Well, I'm going to leave this point here while I draw my line. So my line is going to be starting here, going here. Now, once I get here, this is going to be an open circle. Okay, because 4 is not included with this. Then the next one I'm going to be graphing is y equal 4. So that is going to be a horizontal line, but what's going to happen is I'm going to start here from 4 to 7. And this was a closed dot, but actually now it's going to become a filled in solid dot because this is always y equal 4. So at 4, I do have that value. And then it's going to be coming out. And then we're going to be stopping at 7. But again, this is going to be an open circle at 7. So I'm going to have an open circle here. This is now going to be a solid circle. It wasn't before. And then we have our line. Now, the last one is y equal x. Now, what's going to happen is I would probably put in the first value I want. And that first value I want is a 7. So I would put that into this equation. And when I put 7 in, I end up getting 7 out. So I'm going to have a point up here, solid dot, at 7, 7. And then I'm going up 1 over 1, up 1 over 1, up 1 over 1 till 10. And 10 is going to be an open circle because it says that it's not going to be included. And that's our graph. On number 9, we're going to solve this system. I'm going to use elimination. I'm going to multiply this by 3. So I get a 9x minus 3y is equal to 24. Second equation, I'm keeping the same. 2x plus 3y is equal to 9. I'm going to add these equations together. 11x is equal to 33. So x is 3. And then I'm going to plug it into the first equation. So I get 9 minus something equals 8. So y is going to be 1. So my solution is 2, 3. Now I'm going to do this same thing here in terms of this is a system, but this is not going to be elimination. This is going to be equal values. So I'm going to take x minus 2 squared minus 5 is equal to negative 3x plus 1. X minus 2 squared, that is going to be the following. So that is x squared minus 4x plus 4. That's what that is. And then I still have my minus 5 equals negative 3x plus 1. So I'm going to keep my x squared on this side. I'm going to add 3x to both sides, so I get a negative x. I am going to minus 1 from both sides, so I get a plus 3 equals 0. And then for this, we can try to think of things that multiply to 3 and add to a negative 1, but I cannot. So I'm going to use quadratic formula. So negative b, positive 1, plus or minus the square root of b squared, which is 1, minus 4 times my a, which is 1, and my c, that is 3, all over 2 times my a, which is 1. So when we do this, we're going to get 1 plus or minus the square root of a negative 12 over 2. So this we're going to clean up. So the square root of 12 is a 4 times 3. So that's going to be a 2 root 3. So my answer is going to be 1 plus or minus 2 root 3 all over 2. On 12, so on number 12, we are going to be on A, using trig. If we are here at 36 degrees, this is opposite. This is hypotenuse, so that's going to be sine. So I'm going to go sine of 36 degrees is equal to opposite over hypotenuse. I'm going to multiply by x. And I'm going to divide by sine of 36 degrees. And when I put that into my calculator, sine 6 divided by sine of 36. So I put that into my calculator here, and you see I end up with a negative, which doesn't make sense for a triangle. And you got to remember, you got to come over to the wrench, make sure it's in degrees if you're using Desmos. So this is going to be a 10 point, let's say 2, 1 is going to be our answer. So that is going to be 10.21. On letter B, we're solving for y. So this is going to be a negative 3y is equal to 12 minus 2x. I'm going to divide by a negative 3, divide by a negative 3, divide by a negative 3. Y is equal to negative 4 plus 2/3 x. I could also have had the 12 minus 2x all over negative 3. On C, this is a 45, 45, 90 because this is an isosceles right. And so these are going to both be 5 because we always take our legs and times them by root 2 to get our hypotenuse. On number 13, we have a situation where we are trying to use this formula to determine the height of a ball after it was thrown. And so it says, how long does it take the ball to hit the ground? So I'm going to put 0 in for h. So I'm going to have 0 is equal to 24t minus 4t squared. I'm going to bring the 4t squared minus 24t to the left. I'm going to divide by 4. And then I'm going to factor this. I get t times t minus 6 equals 0. So I get t equals 0 and I get t equals 6. On B, what's the highest point after the ball has reached, point that is reached after the flight of the ball has started? So I'm going to take my x-intercepts, average them. So I get 3. That's the x-coordinate of my vertex. I'm going to put that into the equation. So 24 times 3 minus 4 times 3 squared. And when I work that out, 24 times 3 minus 4 times 9, I get 36. And so the point is 3, 36. The highest it's going to reach is 36 feet in 3 seconds. When was the ball exactly 20? So I put 20 here for my h, and I get 24t minus 4t squared. Again, I'm going to bring the 4t squared minus 24t plus 20 equals 0. I'm going to divide everything by 4. So that's going to give me a 6 here, plus 5. Then I'm going to see if this is factorable. So what multiplies to 5 and adds to a negative 6? So that's going to be a negative 1 and a negative 5. So I get t is equal to 1 and t is equal to 5. So 1 second and 5 seconds on the way back down. And that's the end of this video. Make sure that you understand how to do all of these problems before our chapter test.